This is part 2 of our video on equation applications. So I already did this lesson and got halfway through, and then my phone kept ringing, so I had to stop because I couldn't pause. So I apologize in advance. We're going to go through the parts of the solution that I've already finished, and then we will do the rest together. So our question here says the height of a bungee jumper is shown by the equation h at t equals 4.9t squared minus 49t plus 130, where h is the height of the jumper above the ground in meters, and t is the time since the beginning of the jump in seconds. At what times is the height of the jumper 27.1 meters above the ground? So a bungee jumper is somebody who usually jumps off of a bridge or something high, and they have a really stretchy cord attached to usually their legs or their body, and they jump down, and then the cord, which is very stretchy, pulls them back up. So when I read through this question, I notice that there is a polynomial equation. Actually, it's a quadratic equation because it has a square, and they're telling me that the height is 27.1 meters. And it says at what times, because it says times and it's plural, that tells me there's probably more than one answer. So the first thing I did was I took the equation and I wrote it down. And then everywhere I saw an H, I put in 27.1 meters. So I took out the H and I put in 27.1 equals 4.9t squared minus 49t plus 130. Then from there, I noticed that this was a quadratic equation. So when you're trying to solve a polynomial equation, there are 3 different things you can do. So number 1, you can try to rearrange and isolate the variable. Number 2, you can try to move everything to one side and solve by factoring. And then number 3, you can move everything to one side, and if it follows the right format, you can use quadratic formula. So for rearranging, I notice that I have a t squared and a t. They don't both have the same exponent, which means I cannot just rearrange this. So I would either need to move everything to one side and factor, or move everything to one side and then use quadratic formula. So I started by moving everything over to one side. So I subtracted 27.1 from 130 to get 102.9. So I have 0 equals 49t squared minus 49t plus 102.9. So on this side, there wouldn't be anything left over, so you do need to write something, and that something should be a 0. And when I'm solving, my goal is usually to have that equal 0. So from here, I have a choice. We can factor or try quadratic formula since it has a t squared, a t, and a number. I noticed that there were decimals, which made me not really want to factor this. I feel like maybe we could have common factored out the 4.9 if it divided evenly into the other terms, but I decided to go for quadratic formula. So the 4.9 would be my A, the negative 49 would be my B, and the 102.9 would be my C. So I wrote down my quadratic formula. Now, when I was doing the quadratic formula, we normally write x equals. But because we're solving for t, I wrote t equals, and then negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. When I recorded this the first time, I sang the song. Unfortunately, you're not getting the song this time. So from here, all I did was I put in the numbers for a, b, and c. So I subbed in negative b would be negative 49. So 2 negatives make a positive, so I did positive 49 plus and minus, and then the square root of negative 49 squared. It's really important to have those brackets so that your calculator knows that it's negative 49 that's getting squared, that it knows that those two numbers are together. Then I did minus 4 times a, which is 4.9, times c, which is 102.9, and then all divided by 2a, or 2 times 4.9. All right, our next step is to work out what is underneath the square root and then work out what's in the denominator. So for the part underneath the square root, I had negative 49 squared minus 4 times 4.9 times 102.9 to get 384.16. I have 49 plus or minus 384.16, and then 4.9 times 2 is 9.8, and that was where my phone rang and I got interrupted. So now we're going to keep going from here. The question doesn't say anything about rounding, and it should, because it doesn't really make sense if someone says, at what times is the jumper at this height? It doesn't really make sense to give an answer that looks like that. So that was my fault. I should, in the question, have asked you to round to 2 decimal places. Generally, our rule is that if it doesn't say to round, you shouldn't be rounding, but I'm going to give you permission here because really the intention in the question was for you to round. So first I'm just going to check whether 384.16 has a nice square root, which it actually does. It is 19.6. So I have t equals 49 plus or minus 19.6, all divided by 9.8. All right, so from here, I'm at the point where I need to split this up into the addition and the subtraction. So t is going to be 49 plus 19.6 divided by 9.8. And t equals 49 minus 19.6 divided by 9.8. Okay, so I'm just going to calculate in one step on my calculator. So I'm going to start by doing 49 plus 19.6. It is really important that you hit equals before you divide by 9.8. If you don't hit equals, the only thing that's going to get divided by 9.8 is the 19.6. So I want to hit equals to see what that equals, and then divide by 9.8. And I got 7. So t is 7, and then I'm going to do 49 minus 19.6. Once again, you need to hit equals before you divide. Otherwise, the only thing that gets divided is the 19.6. So equals divided by 9.8, and I get 3. So for all application questions, you really do need to make sure that you write a sentence at the end. So my question was, at what times is the height of the jumper 27.1 meters above ground? That would be at 7, and then it says seconds, and 3 seconds. So I'm going to say, therefore, their height, you could say the height of the jumper, I'm trying to make it a little shorter, is 27.1 meters at, let's do them from low to high. So 3 seconds and 7 seconds. Okay, so that's the end of example number 2. In the next video, we will take a look at example number 3.